Okay, let me just share my screen and then talk through what we're talking about. Okay, so this, can everybody see the issue I've got opened?
Yeah.
Okay, the main thing we're trying to do in this entire decomposition project is to move from having one database with all of the tables in GitLab in it to two databases where one table has all what we're calling CI related tables and the other one's going to be main tables. But an intermediate step in getting us towards that goal is to create a second pool of PGBouncers that still points to the same database. This is an intermediate step in that from the application side of things, it thinks it's talking to two databases, but it saves us in that we don't need to, you know, this is intermediate in that we don't need to figure out how to actually split up those two databases at this point. The tricky problem we're trying to solve now is that when you have a second pool of PGBouncers, that increases the number of connections that will be open to the main Postgres database. And that main Postgres database has some sensible upper limit on the number of connections that we shouldn't exceed for, and also if we get too close to that upper limit in terms of actual usage of that main primary database, we'll also potentially overload it too. So the tricky thing we're trying to solve is that from the application side, we've already figured out how we're going to roll out in percentages. We're going to open connections to both of these PGBouncers. We've already figured out how we're going to roll out gradually and dynamically how many queries to route to each PGBouncer node. But as you start to gradually increase the number of queries going to this PGBouncer CI node, it will start opening more and more connections to the main database. And eventually the main database may exceed the total number of connections. And that's primarily what we're trying to solve. The logical conclusion is, okay, well, we have these limits we can place in here and we will just increase and decrease those in lockstep with this dynamic percentage increase over here. It's a bit more annoying on this side because it requires us to do a reconfiguration of PGBouncer, which is controlled by our deployment pipelines and needs restarts of things, but is doable, or at least needs to reload the PGBouncer configuration. These settings are called max connections, is what it's called in Postgres. Pool size, it seems to be what we use in PGBouncer to set limits here on how many connections the PGBouncer will open to the Postgres database. Although PGBouncer has many configurations that control this, it seems like pool size is the one we're using. Yeah, that I'll stop there. Do people have questions that getting up to speed on that? Does it make sense?
Yes, I'm good.
All good on that. Okay, then I chatted to Nikolai about this the other day and got some pointers as to what we need to think about, as well as then getting some links to what statistics we actually have on all of this and the configurations. This is a configuration for one of the what we call sync PGBouncers, I think, or the web API ones, and we actually will have a different configuration for the Sidekick ones, and actually probably need to get that still. But what we did learn was this. We have, let's see if this loads. I actually am not very good at using the Thanos thing to generate useful graphs, but this is probably much easier, probably a better way to do this than what I've done. But I've just got a stack bar graph that kind of shows us over time the sum of the different connections open from PGBouncer to the primary Petroni database. And there's three different types. There is the active connections, the idle connections, and the used connections. Active connections are ones that are being currently used, something gets moved into an idle connection when it has been idle for 60 seconds, and that's based on some idle period of 60 seconds or 65 server idle timeout 65. So when PGBouncer is supposedly using like first in, last out, I think, or some kind of round robin technique where it tries to use the smallest amount of connections it needs. And so therefore, if you've got 50 connections open and you constantly keep using the same like 10 connections, if that's all you need, and then the other 40 will be moved to idle, I think. That's what's going on based on reading the docs, which are sparse. So something moves to idle connection after 65 seconds, at which point something moves, at which point it gets closed, or maybe it gets closed after 65 seconds and it gets idled in a shorter period of time than that.
Yeah, I think this makes much sense. Yeah.
Yeah, I'm not 100% on exactly how that works, but okay, I don't know. Then I don't know what is the definition of idle. But okay, anyway, I could reread those docs. Used is related to this server check delay. And so it's like, if a server hasn't been used for 30 seconds, it needs to do a server check. And until it does this select one, it sits in the used connections pools, something like that. Anyway, what matters is the sum of these is what Postgres sees on its side. It's seeing this many connections, and they'll be relevant from the perspective of it seeing a limit exceeded and rejecting connections. What we see during low peak times, like probably roughly now, would be some of the lowest usage times in GitLab. And this is the whole weekend here, we kind of have summing up to what looks like less than 250 connections across all the PGBouncer fleet. And it matches some other data that Nikolai collected from Postgres's side of things, where it sees sort of a peak of about 320 connections during peak hours. And maybe
I sent a couple of links to chat, okay. Zoom. I think it's the same. So it's almost the same. This is num backends, but I've sent total count for persistent activity, so it should be the same.
Okay. I'll try to get that chat back up again. Lose the Zoom chat. It's hard to find again. Doesn't like that one. Oh no, it's opening up in my. Damn it! Lately, it just opens in the wrong browser. Client is restricted to use.
It's Thanos, right?
Yeah.
What about the second one, dashboards?
Hold on, let me just see what I might have. Oh yeah, I copied the wrong link. That was the problem. Okay.
Also 300.
Okay, 300 and then going down to like sometimes below 200, but at most sort of 250 during the off-peak times.
Usually cut. It's somehow cut on the top, so we see actual maximums.
Don't see the actual maximums. Why is it doing that?
Thanos doesn't have it, but the first. But okay, we have 300 something, not more than 350. You are right, based on recent observations.
Yeah. Okay. Cool. So based on all of that, and the fact that the limit Postgres can handle is 500, we don't actually want to get anywhere near the 500 limit. But in particular, we don't even want to get near 400 active connections. That being said, if we opened 400 connections during off-peak time, based on most of the data we have here, it would imply that it's unlikely we would even exceed 200 active connections. Like if we even opened 400 connections during off-peak hours, the vast majority of them would be idle, and therefore couldn't possibly lead to an incident, because we're not, throughout this process, we're not increasing the amount of traffic.
Unless application side connection pooler sends some health check query every few seconds or so,
Okay, so we're going to be increasing the amount of health checks based on having a second.
Just I'm not sure about this. Sometimes, for example, for Java applications, it happens. We need to check how application side pullers in Rails behaves.
Yes. The Rails side of things. Okay, so PGBouncer does a select one business that will be a health check. That's cheap. So Rails does checking.
Rails does a semicolon, which is turned out to be like, we in Postgres community right now discussing this, like in Twitter, I saw the discussion today, like this is already considered as anti-pattern because you produce some transaction, but it doesn't have queries. It's really hard to observe it because PGStar statements doesn't have it and so on. So like empty transaction.
What else is Rails doing?
At some point we switched to semicolon, so it's empty transaction. The minimum transaction you can have, just semicolon, right?
Yeah, and there's also wall checks, but wall checks are only happening on the replicas, so probably not relevant for this case. We need to know, for wall checks, we do need to know the state of the primary. Yeah, so I think we will be doubling the number of wall checks we're doing where we ask the primary for its current position. So if you, let me see if I can.
Wall check is, you mean like the control of the leg, right?
Yeah, GitLab itself is keeping track of the primary location, LSN, and then reading the same LSN from all of the replicas to figure out whether or not there's an up-to-date replica. So you can probably see it sometimes in here. That's an LSN. It only shows up sometimes because it's periodic, but you have reminded me with what you just said there. That's kind of a health check that GitLab implements that will probably be doubled in this architecture here of asking, because now we think that there's two primaries. We'll be asking, okay, main, what is your LSN? CI, what is your LSN? So that will also be doubled from the GitLab side. And the semicolon checks, but do we actually think that the select ones and semicolons have like any meaningful impact on load or activity of this? If they finish so quickly, will we be reusing the same connections, or will we be opening lots of connections because of these queries?
What I know, semicolon is half of our transactions, roughly.
By count, but I wonder how much of our active database time it is, presumably.
Well, it's small. So like it produces sort of context switches, but like in terms of CPU load, the impact is quite small. That's why we still have it. We had in the past, we had several times we thought about getting rid of it because there are techniques to get rid of them, but still it's there because it was considered like a lot of work, but benefit is not so huge because the impact on load is not so high. So this is my understanding. I was proposing multiple times to get rid of health checks, and last week one more time. But it's slightly out of like, the question is like, if we give more idle connections, more connections, right? Will they consider be used will they considered as idle after some time, or health checking activities will prevent it? I don't know. So
yeah, that is useful to test out. It's tricky to test all these things, and that's kind of what I might have to get into discussions next. Anyway, I'll jump back to what we were talking about, which is
I guess we need to check on application side on Ruby code what are frequency of these health checks. So
yeah, the frequency will be low and it'll be high because we have hundreds of Ruby nodes, I think will be what we find. But yeah.
By the way, it's a little bit off topic, but at some point I had the idea that these health checking queries do more harm on application nodes than on Postgres nodes. So for Postgres, it's some load, okay, but for application side, it's also significant load. So if we got rid of them, probably we would be able to decrease the number of nodes, Ruby nodes, actually. So, but this is off topic, of course, in this case.
You have an issue that discussed these before, so we can maybe learn how difficult this is. Like maybe it'll end up being something our team can execute on because it makes sense for our team and it's not too tricky. And the only reason it hasn't been done is because it wasn't urgent before, but now it'll become maybe more important.
1 second, I found it. I'm finding it and I will send it when I find it.
Okay. All right. Yeah, so anyway, what we learned from the kind of initial analysis we did was we can probably move over, you know, a reasonably large number of connections at a time. What may be like this PGBouncer main actually consists of 6 PGBouncer hosts today, and we could maybe move 5 from each host corresponding to 30 connections at a time over down here. If we did that, we might get to our target in say like 5 days of having, we haven't done exactly all the maths, but in the end state, we'll be sending roughly half our queries here and roughly half our queries here. So whatever number of connections we have over here today, which is 270, we probably want this thing to end up at maybe 150 and this thing to end up at 150, or it may be a little bit less. This one might be 120 and this one might be 200. That's kind of our end goal. And if we move over 30 connections at a time, it may take us a few days, like if we do it during the quiet times, or we could do 30 and an hour later do another 30 during the quiet hours as well. But or we can do the whole thing over a weekend. But, yeah.
But we know that CI workload is exactly half of the total GitLab workload.
We have some initial analysis we did months ago that said 47% or 43% of write queries relate to CI tables. So, and it will probably vary depending on the time of day, because over the weekends, maybe more workload is CI because it's automated. I don't know. Like, I think it all probably scales pretty linearly with usage as well. But yeah, that's what we know. I mean, it isn't exactly half, and it's probably changed since we did the analysis last time. But I think it would also be good, like after we do the first iteration, let's say we've moved 10% of traffic down here, we can then extrapolate and say, okay, multiply this by 10 in terms of usage. And that's, now we can see the proportionality between the two of them once we've moved some. Because even like percentage of queries doesn't necessarily indicate percentage of, you know, how much PGBouncer CPU usage it needs or whatever, to figure out how many PGBouncer nodes. Okay, that's this issue. I'll link that down here. Okay. Okay, so yeah, that's kind of the plan I've documented here is we start with 1. We create our new PGBouncer CI hosts, and each host will have one, be allowed to open 1 connection to Postgres, and we'll enable 1% of our traffic to of CI related queries to go to these new PGBouncer hosts. Across 6 nodes, that will be 6 primary connections to Postgres. And we in this thing, we will only increase the number of connections to the primary by 6, and therefore we don't need to decrease anything from the existing pool in order to do step number 1. And this may help us iron out some of the kinks, as well as do some analysis on what the next thing needs to be done. We'll wait 24 hours to see what happens during peak and non-peak usage, and then we target doing 5% and 15%, or 5 connections and 15%. That's kind of the rough idea I have so far.
All right, so this is on the first and the second day, and then this is going to roll over the next days, increasing, let's say 10% each day.
Yeah, basically we'll learn from whatever this first day, what happens with these number of connections to figure out what we do on the subsequent days. But yeah, ideally we could do the whole thing in a week, but it's not a problem if we need to be safe and it takes us 2 weeks to roll these things all the way out. So yeah, and basically some of this stuff, you know, depends on how PGBouncer actually closes connections. So we kind of have some assumption that PGBouncer, I mean, it's sort of implied by the documentation, but again, this is sparse, and Nikolai last time mentioned that probably the only way to know is to look at the source code or test it, is basically how it handles closing connections that are idle. If we end up in a situation where this PGBouncer main is, you know, we reconfigure it, we reload the configuration, but it turns out it doesn't close connections when you reload configuration. It only closes connections when you restart it or something like that. Then we need to know that, because that changes exactly the way we execute on this. And we can do rolling restarts of those PGBouncer hosts, presumably without too much trouble. But
there is a recipe how to restart PGBouncer, not interrupting connections, but applying new configuration. So it will wait until ongoing connections are working, processing some queries. I'm sending links in Zoom chat again. Probably, I'm not sure how we did it in the past. Maybe there are some runbooks or automation already existing. I don't know about that. But there is some recipe how to do that, and it should work.
okay. That is without dropping connections from the client, but yeah, in our case, we want to make sure that it does drop server connections when it doesn't need them anymore. I mean, technically that's what PGBouncer already does. It's just a matter of when we lower the limits, how quickly does it drop them? Or if does it even take that lowered connection into account? Or do we need to restart it before it does that? And yeah, so then we have, that's what Jose's created this issue about, and this is kind of like experimenting with this from purely the PGBouncer perspective, but things are a little bit more complicated when we want to experiment the whole thing end to end, which we can do in staging environment. Under some load, we can do a lot of this testing, but the interesting thing here happens is that while on the Rails side, we're tweaking the percentage of queries that go to the different PGBouncer hosts, we're not going to be changing the number of connections we have open to PGBouncer on the Rails side. We assume if we've got 100 connections to PGBouncer here, we can end up with 100 connections down here and here, and that's totally okay, because you've got just as much PGBouncer CPUs, well, you know, more, and we already assume that our PGBouncer number of connections that they have open from clients is not really a problem. We could already increase it today without too much issues. So that's one thing that's a factor to consider here, is like PGBouncer nodes here have still just as many client connections open, but we want them to be starting to lower the number of server connections they have open proportional to how much less queries they're getting on those client connections. Rails is kind of weird, and it's going to be round robining these client connections, and there's not really an easy way for us to drop them live while Rails is running, as far as I know. Or we probably could figure that out if we needed to, but we're hoping we don't have to. Where it is really easy for us to reroute the percentage of queries going down each connection. We don't want to have to close any connections if we can avoid it. So that's like an additional experiment that's kind of hard to do from just this part of the architecture. We need the whole thing to do that experiment, and we can ideally do that in a controlled way on staging. And it's quite difficult for developers like to do this testing locally as well, because we don't run this whole architecture, and it'd be a lot of work for us to get this whole architecture up and running locally. But then even if we did, we wouldn't have the load on the system that allows us to really see what's going on. So staging may be a good candidate for that. Otherwise we are building and deploying some reference architecture that looks like this as well. So maybe that becomes another place we can run these experiments. But
all right. So at wet phase we are now. So we have to deploy the environment in benchmarking to test the PGBouncer behavior, and then move into the staging and start implementing the change in the staging environment. Is that it?
Yeah, I think that's kind of what we've got to do. So basically, from your side, it would be good if we could start doing the experiments from the PGBouncer side and Postgres here to understand how it drops connections. And then, whatever we can learn from reading the docs and the source code of PGBouncer to learn to see and experimenting to see that behavior. Then, from our side, we are implementing the code to do this now, and when we have that code implemented, we could potentially do those experiments on staging, or we may have a reference environment that is similar to actually do those experiments on too. So, and I have like a couple of other things I want to figure out from mine, but also, from your side, like I have collected a bunch of metrics, but you may be able to collect better metrics than what I've got to figure out that the data I have here is maybe not totally the full story.
And also, as I understood, GitLab application implements its own health check query, right? Using select one.
Or apparently empty statements is what we have from GitLab. So PGBouncer does a select one based on looking at our configurations. GitLab sends empty statements, and you can probably see this sometimes when refreshing a page in GitLab. If you look at the performance bar, there's sometimes a query looking at, is it LSN or location, or I can't remember.
LSN, location sequence number.
LSN,
by the way, I'm not sure if it's GitLab, maybe it's Rails, because
it's
previously,
Rails.
Right, it was select one until some point when we switched to this empty query. It was considered
right. So the empty query is Rails, but the LSN query is GitLab because it's part of our load balancing logic. But
I don't know how Finoto was planning to implement this test in the bbench, if it was going to use some benchmarking tool or something like that. We may have to put these health checks into the test in the benchmark for it to make sense, because I think that this is something that can impact the life of a connection, of database connection on the bouncer, because the bouncer does his own health check, right? And as I understand, PGBouncer doesn't consider that health check to keep the connection alive. But if a query came from the application, then PGBouncer is going to consider this as any query, right? So I'm going to see if I can implement a few health checks like this in the benchmarking tool to see if I can put some load of health checks on that, and see if this is going to affect the time, the longevity of the connections on the benchmark environment.
Nikolai, maybe you could help point us to, we probably have a repo somewhere that lists the top queries and the frequency of them, and that can be used.
Right.
This makes sense for you, Nikolai.
But honestly, I usually Jose was running it, so I didn't run it myself, never. So like,
all right.
Launched it. It's Java application, so like, but I will send the link. I can find it right now. I wanted to mention that also Patroni has health check queries, but I guess they go without PGBouncer involved, right?
Yeah, they go directly. Now I'm just worried that these health checks can make the connection sleep longer than they can actually shoot in the bouncer.
Yeah, we should definitely experiment with it. I mean, I'm hopeful that these queries are so quick that PGBouncer is still using a very small set of its connections to round robin those empty statements, and that it's not doing something silly and round robining all 270 connections with empty statements that are all executing very quickly, because that would mean that it would never give up connections. But
Yes.
Yeah, at least for the Rails one, and the purpose of the health check is that something is going to use that connection. So the first thing it does is check whether that connection still works or not. So it's not like something's constantly keeping alive connections for no reason. So I think we're okay there. Yeah, but there is another health controller check, which is slightly different, and that's GitLab as well. That's used for the liveness and readiness checks that Kubernetes has, if I'm not wrong. So, but at most, that's like one database connection per however many seconds that Kubernetes does health checks per pod. Okay. So
okay, you're talking about or is that our GitLab pods in Kubernetes have a health check coming from the Kubernetes controller to check that the pod is still in a good state, and those then cascade to doing a database query so that the pod can say, yes, I have a healthy Postgres connection.
yeah, as part of the liveness or readiness checks, it checks like the GitLab application / readiness check or something like that, right? So each of those pods would have those things, and that does a select one or something like that.
Okay, yeah, if you can find more information about exactly what endpoint that is in GitLab and what query it executes, we'll see that in the, and then we can multiply out that frequency or find it in our logs to see how often that's happening and make sure that's also accounted for in this.
All those queries should be captured in Thanos.
Yeah,
it occurs frequently enough, so you can find it.
Yeah, so theoretically, all the data we need on how often these occur should already be in Thanos, and there's a project somewhere that lists the top N queries of GitLab in a table, and I don't know where that is. I've forgotten, but
Top queries for a table.
Sorry, top queries for all of the GitLab database. It lists in a table format. Like there's a
checkup tool, right? But it will be only by total time. This benchmarking environment, it has two kinds of workload combined: top N by total time and top N by calls. So most frequent, and first is most influential in terms of resource consumption. So most overall time is highest, right? And second is by frequency, the most frequent queries.
Yeah.
I've sent link, right? So
the most frequent queries that table will include these health checks so that we can make sure that they're accounted for in our benchmarking tool.
Mm-hmm.
Well, yes, but this empty, we used PG statements as a basis. By that time, probably we switched to semicolon, and
it's missing.
It went out of consideration, right?
Yeah.
That's why it's like now it's like phantom query.
There's a bunch of other Rails related things when Rails starts up as well that appear in those top N queries, which we were investigating a while back, because when Rails starts up, it asks for the schema of every table. And you would think that's not very frequent, but with the hundreds or thousands of nodes we have and the rate at which we deploy them, those end up in like top N queries as well. It may or may not be accounted for in some of this benchmarking stuff.
Regarding these health checks, I think it's like what we should do. I think we need to check settings, configuration of application nodes, how like to understand the frequency. But this is right. You are right about that. It won't go to every backend, so probably it's not a big deal, right? Because it will affect only some backend during health checking. Others backends are idle and they will go away.
Yeah, well, exactly. That's the ideal situation if PGBouncer behaves sensibly, and we've got it configured in the right way so that it's dropping connections sensibly. But yeah. Well, anyway, all right. There are reasonable action items on there. We can have like another call next week, and also like Raphael, you're in our time zone. It's pretty similar to me and Tom, so we're happy to pair on this or jump on calls and look through some of this stuff with you when that makes sense.
Cool. Yeah. I may have some questions during the trying to implement things because I'm still doing my onboarding. So
Right, getting thrown right into the deep end.
Yeah.
You didn't get an easy project here either. All right.